Have you ever wondered what's happening beneath the surface of the African continent, the very cradle of human civilization? Well, here's a shocker. Africa is actually splitting in two. This incredible geological event is reshaping our world, and most people haven't even noticed. But what does this massive shift tell us about how our planet works? And could it mean we're about to witness the birth of a whole new continent? Get ready, because this crack might be a sneak peek into a future where our way of life has to adapt to a completely transformed world. Africa is a special place for both rocks and early humans. Even before people existed, the continent went through big changes that shaped its landscapes and the way life happened there. To really get why Africa is so important geologically, we need to go way back in time. Picture the continent as a puzzle made up of 5 ancient pieces called cratons: Cape, Zimbabwe, Tanzania, Congo, and West African. These cratons formed a super long time ago, between 3.6 and 2 billion years, and they've stayed pretty solid since then. Then, younger fold belts wrapped around them between 2 billion and 300 million years ago, and these rocks got all folded and changed by heat and pressure. If you look at more than half of Africa's surface, you'll see old rocks from way back when, belonging to something called the Archean Age. The oldest ones are in places like the Cape, Zimbabwe, and Congo cratons. These rocks tell a story of things like underwater bursts and really hot formations. There's even a rock type, komatiite, that mostly hangs out in the Archean. As time goes on, about 2.5 billion to 541 million years ago, we enter the Proterozoic. This is when we see the birth of mobile belts, areas where rocks got squished and changed a lot. This squishing probably happened because cratons were crashing into each other, thanks to plate tectonics. You can find these belts all over Africa, from the Limpopo Belt between the Cape and Zimbabwe cratons to the Khyberine belts in eastern and southern Africa. The end of the Precambrian era, around 950 to 550 million years ago, brings us a big geological event called the Pan-African episode. This led to the creation of long belts, like the Mozambique Belt on the east coast, and the Mauritania Belt stretching from Senegal to Morocco. These belts are like wrinkles in the Earth's skin, telling a story of ancient collisions and changes in Africa's makeup over time. Why does this geological history matter? Well, it's the backdrop for one of the most fascinating things happening right now. The seemingly solid ground beneath us is always moving, quietly reshaping the world. Nowhere is this more evident than in East Africa's Great Rift Valley, a geological wonder tearing the continent apart. In 2018, the world witnessed a jaw-dropping event in Kenya. A giant crack appeared, a visible sign of the powerful forces beneath the surface. This crack, stretching kilometers long and tens of meters wide, wasn't just a passing oddity. It signaled a massive geological shift. The Great Rift Valley, running from the Red Sea through eastern Africa to Mozambique, has intrigued geologists and anthropologists for a long time. It's not just a geographical marvel. It's a living testament to the dynamic forces shaping our planet. In 2018, near Mamahiu in Kenya, this geological drama took a dramatic turn. A giant crack, several meters wide and many kilometers long, seemingly appeared overnight, causing panic and displacement. Roads were severed, properties split, and disbelief filled the air. Why did this enormous fissure suddenly show up in the Earth's crust? The answer lies in the ongoing growth of the East African Rift. This rift system, an active divergent tectonic boundary, is slowly pulling the eastern part of the African continent away. As the African plate tears apart, molten magma rises, splitting the land and eventually forming a new ocean. The Kenya crack was a manifestation of this process, a reminder of the immense geological forces beneath us. The East African Rift isn't new. It's been shaping the continent for millions of years. However, the 2018 crack brought it to global attention. This rift system plays a crucial role in the continent-splitting phenomenon. As the rift widens, it's believed that in the distant future, the eastern part of Africa will break off, forming a new continent and leaving behind a new ocean. The crack story doesn't stop with its sudden appearance. Since it showed up, the crack has been growing, showing how the Earth's crust in this area is always changing. Satellite images and observations on the ground reveal that the crack is getting bigger, making the idea of a continent splitting more real each day. This rift formation has made diverse habitats, From high plateaus in Ethiopia to low savannas in Kenya and Tanzania, these habitats are home to many different plants and animals, some of which you won't find anywhere else on Earth. The East African Rift also gives us a peek into our planet's deep history, teaching us about how tectonic plates, mantle dynamics, and continental rifting work. The appearance of this rift highlights that the ground we walk on isn't as still as it seems. The Earth's lithosphere, the rigid outer layer, isn't one unbroken shell. It's divided into pieces called tectonic plates, moving slowly on the semi-fluid asthenosphere below. But what happens when these massive plates decide to move apart, creating new landforms and changing the face of our planet? Tectonic plates are huge pieces of solid rock that fit together and float on the Earth's semi-fluid asthenosphere. These plates shape the Earth's landscapes, forming mountains, ocean basins, and continents. The constant movement of these plates is powered by heat from the Earth's interior, creating currents that push the plates in different directions. Now you might be curious about how the movement of these tectonic plates creates continents. Well, the answer lies in the fascinating process of continental rifting. Continental rifts are areas where the Earth's lithosphere is pulled apart by tectonic forces. This rifting process is like the early stage of continental breakup, eventually leading to the birth of new ocean basins and the breaking apart of continents. The role of tectonic plate movement in forming continents is crucial. When plates move away from each other, it causes the continental crust to thin and stretch. This stretching results in a rift valley, a noticeable depression between highland regions. As the rift valley gets deeper and wider, magma from the mantle rises to fill the gap, solidifying into new crust. Over millions of years, this process can cause continents to split and new ocean basins to form. But is Earth the only planet with tectonic activity, or do other celestial bodies in our solar system experience the dance of the plates? Interestingly, while Earth is the only known planet with active plate tectonics, there's evidence suggesting that Mars and Venus might have had tectonic activity in their geological pasts. Now let's dive into the world of continental rifts. These geological wonders are not just cracks in the Earth's crust. They are dynamic regions where different forces shape the future of continents. The birth of a continental rift is a geological spectacle, marking the start of continents breaking up and forming new oceanic areas. In Africa, tectonic plate movement and continental rifts are crucial. The continent is changing geologically, quietly evolving beneath our feet as tectonic forces create a new geological entity. The East African Rift System shows how dynamic the Earth's lithosphere is, serving as a real-life lab for studying continental rifting and plate tectonics. Could these powerful forces shape our planet enough to create a new continent soon? Absolutely. The ongoing rifting in Africa hints at the birth of a new continent, a huge event that will change how we understand the Earth. To understand the scale of this geological event, let's go back to a time when the Earth was very different. Picture a time when all the continents we know today were joined in a supercontinent called Pangaea. Coined by Alfred Wegener in 1912, Pangaea was a massive landmass that existed around 335 million years ago during the late Paleozoic and early Mesozoic eras. But how did we discover Pangaea? And what supports its existence? Clues in rocks and fossils show alignment of mountain ranges, similar rock formations, and fossil distribution across continents. Fossils, like Mesosaurus in South America and Africa, suggest past connections between continents. Coal beds in ice-covered Antarctica also indicate a once temperate climate and connection to other continents. The geological puzzle reveals a united world with intertwined landmasses and interconnected ecosystems. Pangaea's fate was sealed as movements beneath the Earth's crust led to its breakup, forming two colossal landmasses. As continents continuously move and reshape, what's the future of our planet's geography? The Eastern Africa Rift foretells unprecedented changes, not just a geological marvel, but a herald of transformations in topography, climate, and global trade dynamics. Africa's split predicts the birth of the world's sixth ocean as the Red Sea floods the Rift Valley. This will reshape coastal boundaries, create new shorelines, and possibly give rise to new port cities. Emerging maritime routes will impact global trade, reshaping economic landscapes and fostering new trade relationships. Imagine if a new ocean is born next to some African countries. What would that mean for them? Well, it's a mix of exciting possibilities and potential challenges. These nations will need to adapt and make the most of the new opportunities this geological change brings. With new ocean boundaries, there's a chance for increased trade and commerce. Picture the growth of port cities and better maritime routes, connecting African nations with the rest of the world. This boost in trade could lead to more economic growth, investments, and progress in various areas like tourism, fisheries, and maritime industries. Yet, it's not all smooth sailing. The changes might shake up the balance of power and economics in the region. New borders and maritime zones might stir up disagreements, needing negotiations among nations. How well they handle these challenges through talking and cooperation will be crucial for keeping the region stable and sustainable. And here's an interesting twist. The shifting landscape could uncover valuable geological treasures. Exploring these new areas might not only teach us more about Earth's history, but also open up chances to find untapped mineral resources. Imagine the economic opportunities that could bring. So it's a bit like a puzzle, exciting, challenging, and full of potential. Let's see how these nations navigate these changes for a better, more connected future. Now let's focus on the impact of this big geological transformation on the environment. The birth of a new ocean is not just about changing landscapes. It's a game changer for the Earth's systems. Firstly, creating a new ocean will shake up the way our oceans move and the air flows. Ocean currents and atmospheric circulation will be different, affecting how and where it rains and the temperatures in the region. This can bring challenges for agriculture and water availability, making it important to come up with smart ways to deal with these changes and ensure we still have enough food and water. But what about the plants and animals in Africa? The shift in climate might push some species to evolve and others to disappear. The whole structure of ecosystems in the region will change. New places to live, both on land and in the sea, will lead to species moving, adapting, and even evolving into something new. This could create new and unique ecosystems with special plants and animals. Yet, these changes also pose a threat to existing ecosystems, putting some species at risk if they can't adapt quickly enough. And don't forget about sea levels. The birth of a new ocean will move around a lot of water on Earth. This shift could cause some areas near the coast to end up underwater. Imagine the impact on low-lying areas. It could make the problems we're already dealing with, like coastal erosion, saltwater getting into freshwater sources, and being more at risk during storms, even more challenging. So, it's not just about a new ocean. It's about how the Earth's whole system responds, and how we adapt to these changes to keep things in balance. The way continents break apart and interact with the surrounding seas affects things like ocean currents, temperatures, and salt levels. These changes impact sea life, affecting where animals live, how they behave, and if they can survive. This can mess up the food chain in the ocean, which is bad news for fishing and the people who depend on the sea for their livelihoods. When continents split, things like volcanoes and earthquakes happen. Volcanoes release gases and particles that can mess up the air, climate, and soil. Earthquakes can cause landslides, tsunamis, and shake the ground, which is dangerous for both nature and buildings. NASA, the space and Earth science experts, are using a special satellite called Landsat 9 to closely watch and understand what's happening on Earth's surface. This satellite, a teamwork effort with the U.S. Geological Survey, gives us important information about geological events and their impacts. What are we doing to get ready for the big effects of these events? We're creating early warning systems, making plans for people to evacuate if needed, and building strong structures that can handle these geological shakeups. These plans aim to keep people safe, protect nature, and make sure important services keep running when the Earth does its unpredictable moves.